Combinations of functions. Sometimes we need to combine functions. Functions can be added, subtracted, multiplied, and divided. We sometimes need to plug one entire function into another function. This first example says, for the indicated functions f and g, find the functions f plus g, f minus g, f times g, and f divided by g. Your book instructions also say find their domains. We're not going to do that this time. So first let's do f plus g. We're just adding the two functions, 3x plus x squared plus 4. There are no like terms here, so you can just leave it the way that it is, or if you would rather have it in order, it would be x squared plus 3x plus 4. F minus g. Whenever I'm subtracting, it's a good idea to put the second term in parentheses so that you'll remember to distribute the minus. So it would be 3x minus parentheses x squared plus 4. That helps you remember that this minus, the subtraction, affects both the x squared and the 4. So then we have 3x minus x squared minus 4. And again, if you would like to rearrange that, you don't have to. It would be negative x squared plus 3x minus 4. F times g, we're multiplying 3x times x squared plus 4, and distribute. Then it's 3x cubed plus 12x. And then finally the division, you just put the first one over the second one, 3x over x squared plus 4, and that's all you have to do. Let's try another one, same instruction. There are two functions, so first we do f plus g. Sorry, pen's not doing right. F plus g is 6x squared minus x minus 1 plus x minus 1. Now I have some like terms to combine. The x's will cancel, and minus 1 and minus 1 make minus 2. So it's 6x squared minus 2. F minus g. Again, let's put the second one in parentheses, so we have 6x squared minus x minus 1 minus parentheses x minus 1. Then we remember that the minus in front of the parentheses distributes. That gives us 6x squared minus x minus 1 minus x plus 1. Now combine like terms. We have 6x squared. Our x's minus x and minus x would be minus 2x, and the 1's would cancel. F times g. So we've got 6x squared minus x minus 1 times x minus 1. Whenever I have 3 terms times 2 terms, I usually start with the 2 terms. And I'm going to distribute twice. So looking at the back, the x, I'll distribute it times everything in the first parentheses, and then I'll distribute the negative 1 times everything in the first parentheses. So distributing the x will give me 6x cubed minus x squared minus x, and then distributing the negative 1 minus 6x squared plus x plus 1. Now let's combine like terms. I've got a 6x cubed, then my x squared, a minus 1, and a minus 6 make minus 7. The x to the first power will cancel, and then I just have plus 1. Finally, f divided by g, just put the f function over the g function and be done with it. When we're plugging an entire function into another function, this is called composition of functions. The f with the little open circle, g notation is used. That's read f of g. And then you see the other one is g of f. Some textbooks use this notation, f of g. Whichever notation is used, the one on the right, the function on the right, will plug into the function on the left. It will replace the x. So we're supposed to do f of g and g of f. Let's start with f of g. The one on the right goes into the one on the left. So the entire g function, 2x plus 3, replaces the x in the f function. Here's what that looks like. We have absolute value, and then where the x was, we're going to put 2x plus 3. And then there's a plus 1. So the g function plugged into the f, where the x was. Now inside the absolute value, I can combine like terms, 2x plus 4. Now let's go the other way around. So let me say again what I did. Let me show you with arrows. I put the 2x plus 3 in for that x. So let me rewrite the problem. Now we're going to go the other way around. We're going to find g of f. The one on the right goes into the one on the left. So the entire f function, absolute value and everything, comes over and plugs into the g function where the x was. I have a 2, and where the x used to be goes absolute value of x plus 1, and then plus 3. That's all you can do with that. You can't distribute into an absolute value. Now, f of x equals x plus 2. G of x equals 1 over x. So first let's find f of g. The one on the right plugs into the one on the left, so the 1 over x replaces the x. And we have 1 over x and then a plus 2. Now back to the original. And going the other way around, g of f. The one on the right replaces the one on the left. So 1 over x. Oops, I did that backwards. So x plus 2 goes in for the x. And we have 1 over x plus 2. Here's another one, same instructions. We want to find f of g and g of f, so f of g first. The one on the right plugs into the one on the left. So the x squared replaces the x in the f function. Then we have the square root of 4 minus, and where the x used to be, we put an x squared. Back to our original. Now we're going the other way around, g of f. The one on the right plugs into the one on the left. So the entire f function, square root and everything, comes over and plugs in for x. Square root of 4 minus x, and then because the original x was squared, this square root was squared. When you square a square root, they cancel out. So I'm just left with 4 minus x. I want to caution something from above, the square root of 4 minus x squared. Sometimes it's very tempting, because 4 is a perfect square and x squared is a perfect square, to try to square root that and write that as 2 minus x. But if you have add or subtract underneath the square root, you can't take the square root of each individual term. So that's not true. You can't do that. Be careful about that. Okay. Same instructions. Now we have, first of all, f of g. and we're going to take the entire g function and put it where the x was in the f function. So we'll have 4 plus, and now where the x used to be, we write 2x squared plus x plus 5. And I have some like terms to combine. So that would turn out to be 2x squared plus x plus 9. Now let's look again at how the original functions were. And we're going to do g of f. The one on the right plugs into the one on the left. Now there's more than one x here. So every time I see an x, I'm going to have to replace it with 4 plus x. Then we have 2 times 4 plus x all squared plus 4 plus x plus 5. 4 plus x squared, anytime you square something, you have to write it twice and multiply it by itself. So 4 plus x times 4 plus x, and we'll have to FOIL that. I can go ahead and combine 4 and 5. So in the back we have x plus 9. So FOILing will give me 16 for first. Outside is plus 4x. Inside is plus 4x. Last is x squared. There's a 2 to be distributed. 32 plus 8x plus 8x plus 2x squared, and then plus x plus 9. Now we need to combine some like terms. There is a 2x squared. Then x to the first power would be 8 plus 8 plus 1, which is 17. And we are left with a 9, 32, and a 9, 41. And that one's finished. Sometimes we're given the composition and then we're asked to determine the original two functions. This says express h as a composition of two simpler functions, f and g. The easiest thing to do is have g be the inside and f be the outside. Inside means it's sealed up in something, in parentheses or under a square root, maybe underneath a fraction, something like that. It's sealed up in something, in absolute value bars. So the g part's pretty easy to figure out. The inside of this would be the 2x minus 7. It's trapped inside parentheses. Then what you can do is if you'll erase out what you just wrote down, the 2x minus 7, and replace it with an x, then that will be the f function. F of x equals x to the 4th. Now there's really more than one correct answer to these and more than one way to do these, but this is the simplest. This is a process that we have to use sometimes in calculus, figuring out the inside and the outside. Let's do one more of those. So the inside is the part trapped, which would be 4 plus 2x. Now let's at least mentally get rid of what we just wrote down, and where it used to be we'll put an x. And that's the f function, the square root of x.